There are two methods to install can lights in vinyl soffit. Firstly, the surface-mounted cans method, and secondly, the suspended cans method. The surface-mounted cans method involves several steps. Firstly, use light-emitting diode or LED can lights with a surface mount design. Secondly, mark the desired locations on the soffit. Thirdly, pre-drill holes for the electrical wire. Fourthly, feed the wires through the holes and connect them to the cans. Fifthly, secure the cans to the soffit using screws or construction adhesive. Sixthly, patch around the edges of the cans with caulk to prevent air leakage. The suspended cans method also involves several steps. Firstly, install hanging wires from the attic joists above the soffit. Secondly, attach the cans to the wires using wire hooks or cable ties. Thirdly, adjust the height of the cans as needed. Fourthly, feed the electrical wire through the attic and connect it to the cans. Some general tips to remember are: firstly, choose cans with a lightweight construction, such as plastic or aluminum. Secondly, use plastic or flexible conduit for the electrical wire to prevent damage to the soffit. Thirdly, install weather-resistant gaskets around the edges of the cans to prevent moisture intrusion. Fourthly, consider using motion-activated or photocell-controlled cans to save energy. It is very important to hire a licensed electrician for the electrical work, especially if not comfortable working with electricity. Electrical work involves dealing with voltage, amperage, and resistance. Voltage is the electrical potential difference measured in volts. Common voltage levels in residential settings include 120 volts and 240 volts. It's crucial to identify the voltage of the circuit before working on it to prevent electrical shock or damage to equipment. Amperage is the measure of electrical current flowing through a circuit measured in amps. Each circuit has a maximum amperage rating typically determined by the circuit breaker or fuse protecting it. Overloading a circuit by drawing more amps than it's rated for can cause the breaker to trip or, in more dangerous situations, lead to overheating and fire. Resistance is the opposition to the flow of electrical current measured in ohms. Electrical components, such as resistors, are designed to provide specific resistance values. Understanding resistance is important in circuit design and troubleshooting to ensure proper operation and prevent damage. Grounding is another very important electrical safety concept. Grounding provides a path for electrical current to flow safely back to the source in the event of a fault. This helps to prevent electrical shock and minimize the risk of fire. Ground wires are typically green or bare copper and should be properly connected to all electrical outlets, fixtures, and appliances. Circuit breakers and fuses are overcurrent protection devices that protect electrical circuits from damage due to overloads or short circuits. Circuit breakers are resettable switches that trip open when the current exceeds the breaker's rating, while fuses are one-time use devices that melt and break the circuit when the current exceeds the fuse's rating. It is important to use the correct size breaker or fuse for each circuit to provide adequate protection. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Electrical inspectors use the NEC to ensure that electrical work meets minimum safety standards. Some examples of NEC articles are 310.15, which covers ampacity of conductors, and 250.122, which covers equipment grounding conductor sizing. When working with electrical wiring, it's important to use the correct type and size of wire for the application. Wire size is measured in American wire gauge, or AUG, with smaller numbers indicating larger wire sizes. The appropriate wire size depends on the amperage rating of the circuit and the length of the wire run. Using undersized wire can cause overheating and voltage drop, while using oversized wire is generally unnecessary and more expensive. Wiring methods refer to the way electrical wires are installed and protected. Common wiring methods include non-metallic sheath cable or NM cable, also known as Romex, used for residential wiring, electrical metallic tubing, or IMT, used for exposed or concealed locations, and rigid metal conduit, or RMC, used for heavy-duty applications. Each wiring method has its own set of installation requirements and restrictions. Electrical boxes are used to enclose and protect electrical connections. They come in various shapes and sizes and are typically made of metal or plastic. Electrical boxes must be properly installed and grounded to ensure safety. Proper wiring connections are essential for reliable and safe electrical systems. Wires should be connected using approved methods such as wire connectors, also known as wire nuts, or terminal screws. Connections should be tight and secure to prevent loose connections, which can cause overheating and electrical arcing. When working with electrical circuits, it's important to use proper lockout and tagout procedures to prevent accidental energization. This involves turning off the circuit breaker or disconnecting the power source and attaching a lockout tag to the disconnect switch to indicate that the circuit is being worked on. Only authorized personnel should remove lockout tags. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. They monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or FCIs, are designed to protect against fires caused by electrical arcing. They detect abnormal arcing conditions in electrical circuits and quickly interrupt the power. FCIs are typically required in bedrooms and other areas where people sleep. Electrical panels, also known as breaker boxes, are the central distribution point for electrical power in a building. They contain circuit breakers that protect individual circuits from overloads and short circuits. Electrical panels should be properly labeled to indicate the circuits they control. Electrical permits are required for many types of electrical work, especially new installations, additions, and alterations. Permits ensure that electrical work is performed according to code and that it is inspected by qualified electrical inspectors. It is important to obtain the necessary permits before starting any electrical work. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical work meets safety standards. Inspectors check for proper wiring methods, grounding, overcurrent protection, and equipment installation. It is important to cooperate with electrical inspectors and address any issues they identify. Troubleshooting electrical problems requires a systematic approach. Start by identifying the symptoms of the problem and then use a process of elimination to isolate the cause. Common electrical problems include tripped circuit breakers, blown fuses, dead outlets, and flickering lights. Electrical safety is paramount when working with electricity. Always turn off the power before working on any electrical circuit. Use insulated tools and equipment. Avoid working in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, but by following safety precautions and working carefully, you can minimize the risk of electrical shock and fire. In addition to the safety aspects, understanding the different types of can lights available is beneficial. Recessed can lights, also known as downlights, are installed flush with the ceiling, providing a clean and unobtrusive look. They are commonly used for general lighting and accent lighting. Asphalt trim can lights have a grooved interior that reduces glare and provides a softer light output. They are often used in living rooms and bedrooms. Adjustable trim can lights allow you to direct the light beam to a specific area, making them ideal for highlighting artwork or architectural features. Gimbal trim can lights have a rotating and tilting center section, providing even more flexibility in directing the light. Eyeball trim can lights have a small, round opening that directs the light beam in a narrow focus. They are often used for accent lighting and task lighting. Slope ceiling can lights are designed for use in ceilings with a slope or angle. They have an adjustable housing that allows the light to be directed straight down. Insulation contact, or IC, rated can lights are designed to be installed in ceilings with insulation. They have a special housing that prevents the insulation from overheating and causing a fire. Non-insulation contact, or non-IC, rated can lights are not designed to be installed in ceilings with insulation. They require a minimum of 3 inches of clearance from insulation to prevent overheating. When selecting can lights, it is important to consider the size, shape, and wattage of the bulb. Common bulb types include incandescent halogen, compact fluorescent, or CFL, and light-emitting diode, or LED. Light-emitting diode, or LED, bulbs are the most energy efficient and have a long lifespan. The color temperature of the bulb affects the appearance of the light. Warm white bulbs have a yellowish tint and are often used in living rooms and bedrooms. Cool white bulbs have a bluish tint and are often used in kitchens and bathrooms. Daylight bulbs have a neutral tint and are often used in offices and workspaces. The light output of the bulb is measured in lumens. A higher lumen rating indicates a brighter light. When planning the layout of can lights, it is important to consider the size of the room, the height of the ceiling, and the desired level of illumination. A general rule of thumb is to space can lights evenly throughout the room, with a distance of 4 to 6 feet between each light. For higher ceilings, you may need to increase the spacing between the lights. When installing can lights in a vinyl soffit, it is important to use the correct type of mounting hardware. Surface mount cans can be attached to the soffit using screws or construction adhesive. Suspended cans can be attached to the attic joist using wire hooks or cable ties. It is important to make sure that the mounting hardware is strong enough to support the weight of the can lights. When wiring can lights, it is important to follow the National Electrical Code, or NEC, guidelines. Wires should be connected using approved methods, such as wire connectors or terminal screws. Connections should be tight and secure to prevent loose connections, which can cause overheating and electrical arcing. When working with electrical circuits, it is important to use proper lockout and tagout procedures to prevent accidental energization. This involves turning off the circuit breaker or disconnecting the power source and attaching a lockout tag to the disconnect switch to indicate that the circuit is being worked on. Only authorized personnel should remove lockout tags. After installing can lights, it is important to test them to make sure that they are working properly. Turn on the circuit breaker and check each light to see if it is illuminating. If a light does not work, check the bulb and the wiring connections. With proper planning and installation, can lights can provide a beautiful and functional lighting solution for any space. Remember to prioritize safety and consult with a qualified electrician if you are not comfortable performing the electrical work yourself. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before starting any electrical project.